Have you ever wondered if we could make MRI machines cheaper, more portable, and just as powerful? Well, a recent breakthrough in magnet design might just bring that future closer than you think. Physicists Professor Ingo Rehberg and Dr. Peter Blumler have turned some long-held assumptions about magnets on their head. Historically, the gold standard for creating a homogeneous magnetic field was the Halbach array. We're talking about magnets arranged in a circle, ideally of infinite length, generating a uniform field in the center. But here's the catch. Infinite magnets aren't exactly practical for real-world devices, especially if you want them to fit into a clinic or lab. What happens when you try to use a Halbach array with real finite magnets? You lose both strength and uniformity. The field becomes patchy, and that's a big problem for sensitive applications like MRI, where consistency is everything. Rehberg and Blumler set out to solve this. Their approach? Rethink the arrangement entirely. They modeled magnets not as lines, but as point dipoles, and looked at how to orient them in compact, three-dimensional structures. They tested two main geometries, a single ring and a stacked double ring. Plus, they introduced a focused design, which can generate homogeneous magnetic fields not just inside, but also outside the plane of the magnets. Imagine placing a sample above the magnets and still getting that crucial field uniformity. Of course, theory is just the first step. To prove their point, they built magnet arrays with 16 Fend-B cuboids, mounted on custom 3D printed supports. They meticulously measured the resulting fields and compared them to their calculations. The result? Excellent agreement. Both in terms of field strength and homogeneity, these new designs outperformed the classic Halbach setup and its variants. So, why does this matter for medicine? MRI relies on strong, uniform magnetic fields to form clear, detailed images of soft tissue. Superconducting magnets get the job done, but they're expensive and complex. That puts MRI out of reach for many hospitals and clinics around the world. If we can replace those systems with permanent magnet arrays that deliver comparable performance, suddenly MRI becomes more accessible, portable, and affordable. And it's not just MRI. These advances could impact particle accelerators, magnetic levitation systems, and plenty of other technologies that rely on precise magnetic fields. It's a perfect example of how a bit of creative thinking and some rigorous physics can bring real change to medicine and engineering. Who knows? The next time you step into an MRI scanner, you might just be surrounded by magnets arranged in ways no one had imagined before.